Hey everyone, let's solve one previous question of recurrence relation. This question was asked in GATE CS 2023, question number 5. The Lucas sequence Ln is defined by the recurrence relation L of n equals to L of n minus 1 plus L of n minus 2 for n value greater than equals to 3 with L of 1 equals to 1 and L of 2 equals to 3. Which one of the option given is true and 4 options are given. I already discussed similar type of question in Fibonacci sequence during lecture. Just go through lecture, then come to this question that you can understand. So we have the recurrence relation L of n equals to L of n minus 1 plus L of n minus 2, and we have the initial condition L of 1 equals to 1 and L of 2 equals to 3. First, we need to write the characteristic equation. How will find the characteristic equation? In place of L of n, we'll write r power n equals to r power n minus 1 plus r power n minus 2, and both side will divide by r power n minus 2. So after division, here it will be r square equals to r plus 1. Now take to left side, so r square minus r minus 1 equals to 0. This is our characteristic equation. We got the characteristic equation. Next, we need to find root of the characteristic equation. We need to find characteristic root of it. So let's check, is there any two number whose multiplication will be minus 1 and addition will also minus 1? No, there are no such numbers. So we'll apply the formula. What is the formula? Minus b plus minus b square minus 4ac root over divide 2a, and here a equals to 1, b equals to minus 1, c equals to minus 1. Now substitute all the value in this formula. So after substitution, we got 1 plus minus root 5 divide 2. So r1 equals to 1 plus root 5 divide 2, r2 equals to 1 minus root 5 divide 2. Now solution of the recurrence relation will be L of n equals to alpha 1 plus root 5 divide 2 power n plus alpha 2 1 minus root 5 divide 2 power n. So this is the solution of the recurrence relation. Now check the option. From options, option B and option C are ruled out, as here there is 3, but in our solution both denominator are 2. So just option A and option B left. For option A, if you consider alpha 1 equals to 1 and alpha 2 equals to 1. For option D, if we'll consider alpha 1 equals to 1 and alpha 2 equals to minus 1. So let me take alpha 1 equals to 1 and alpha 2 equals to 1. Now I will check the initial condition. L of 1 equals to 1. So in place of n, we'll write 1, right? And alpha 1 is 1, alpha 2 equals to 1. So L of 1 equals to 1 plus root 5 divide 2 power 1 plus 1 minus root 5 divide 2 power 1. Now simplify it. 2 1 plus root 5 plus 1 minus root 5. So this plus root 5 minus root 5 will be cancelled. 2 divide 2, it's 1. So yes, when alpha 1 equals to 1, alpha 2 equals to 1, L of 1 equals to 1. Let's check L of 2. L of 2 equals to 3. So 1 plus root 5 divide 2 square. In place of n, we'll write 2. Right? Plus 1 minus root 5 divide 2 square. We know a plus b whole square equals to a square plus b square plus 2ab, and a minus b whole square equals to a square plus b square minus 2ab. So I'll write 1 plus 5 root 5 square is 5 plus 2 root 5 plus 1 plus 5 minus 2 root 5 minus 2ab divide 4, right? So 2 root 5 minus 2 root 5 will be cancelled. 1 plus 5 is 6, 1 plus 5 is 6, 6 plus 6 is 12, 12 divide 4 is 3. Yes, for alpha 1 equals to 1, alpha 2 equals to 1, L2 value is also 3. So both initial condition satisfy. Now check for alpha 1 equals to 1, alpha 2 equals to minus 1. So L of 1 equals to 1 plus root 5 divide 2 minus, in place of alpha 2 we are writing minus 1 minus root 5 divide 2. Okay, we are just checking option D whether it can be true or not. Option A we found true, option B and option C we found wrong. Now solve it. 2, 1 plus root 5 minus 1 plus root 5. So plus 1 minus 1 will be cancelled. 2 root 5 divide 2, 2 to cancel root 5. Root 5 is not same as 1. Okay, so option D is wrong. Alpha 1 value can be 1, but alpha 2 value cannot be minus 1. Alpha 2 value is 1. So we found option B is wrong, option C is wrong, option D is wrong. Only answer is option A. For alpha 1 equals to 1 and for alpha 2 value equals to 1. Okay, we check both initial condition, it satisfies. So here answer will be option A. Actually, you don't need to find the characteristic equation, characteristic root and the solution. Simply in place of n, put 1 and check further L of 1 equals to 1 or not. In option A, in place of n, put 1, check further this value is 1 or not. In option B, option C, option D, check. For option A, it will be 1, while for option B and for option C, for option D, it will be not 1. Even you can check for L of 2 equals to 3. In place of n, substitute 2 and check further that value equals to 3 or not. So you don't need to find the solution of the recurrence relation. Just for your understanding, I explained in detail. You don't need to do. In place of n, write 1 and check whether it is 1 or not. In place of n, write 2 and check whether this value is 3 or not. Only option A satisfies the initial condition. So answer is option A. I already discussed recurrence relation during lecture. Just go through the lecture, and if this lecture is helpful for you, please like, share and subscribe. Thank you.